Hello everyone, this is Teacher Wade and welcome back to my YouTube channel, Teacher Wade TV. We are here on the open field so that we can avoid unnecessary noises because we are going to continue the lesson that we had last time. And without second thought, let's get started. In this video, we are going to continue the lesson that we had last time, which was all about finding the nth term of a sequence. But this time, we are going to use another set of numbers having different pattern. For example, we have 3, 6, 9, and 12. As you can see, we can easily get the pattern of these numbers by doing it manually, and that is by adding 3 to the preceding term. Now, let's take a look at this. We get 6 by adding 3 to the preceding term, which has the value of 3, and we can get 9 by adding 3 to the second term, which is 6, and we can get 12 by adding 3 to the third term, which is 9. However, this method may take time, especially if there is no preceding term. So, we need to formulate a specific rule for this sequence. And as what we have noticed, the value of its term is a multiple of 3, and our pattern is increasing by 3. Therefore, our rule for this sequence must be 3n, and we are going to denote f sub n to represent the number of terms in the sequence. So, n here represents the number of term in the sequence. So, we will try this one. So, we will try if we can get 3 for the first term. So we have f sub n equals 3n, and then we are going to substitute n for the first term. So we are going to substitute n by 1. So we have f sub 1 equals 3 times 1. So our first term is 3. So it is correct. Let us try using the fourth term. So we have f sub 4 equals 3 times 4. So our f sub 4 is equal to 12. So our fourth term for this sequence is 12. If you are required to look for the value of the specific term in this sequence, you can just use this formula, f sub n equals 3n. For example, if you are required to look for the value of the 15th term in this sequence, so you can just substitute 15 for n. So we have f sub 15 equals 3 times 15. So we have 3 times 15 is equal to 45. So our 15th term for this sequence is equal to 45. Now, let us have our second example. We have 1, 4, 9, and 16. And as we look at these numbers, we can conclude that they are all perfect squares. Therefore, the rule for this sequence must be n raised to the power of 2, or a perfect square. So our formula is fn is equal to n raised to the power of 2. Now, let us try to check if this formula will work in this sequence. So we have So we will try the second term. So we have f sub 2 is equal to 2 raised to the power of 2. So 2 raised to the power of 2 is equal to 4. So our second term is equal to 4. Now we will try to look for the sixth term using this formula. So we have f sub 6 is equal to 6 raised to the power of 2. So we have 6 times 6 equals 36. So the value for our sixth term in this sequence is 36. Let us have another example. We have 2, 5, 8, and 11. Since the pattern is increasing by 3, we can try 3n as its rule. And let us check if this is correct. Now we will try to check the value of the first term using this formula, and let us find out if we can get 2. So we have f sub 1 equals 3 times 1. So our first term using this formula is 3. Since we have the value of 3 using 3n, we have to subtract 1 from 3n to make it 2. So we have 3n minus 1 as a rule for this sequence. Now let us try using this rule. We will try for the third term. So we have f sub 3 equals 3 times 3 minus 1. So we have f sub 3. 3 times 3 equals 9 minus 1. So we have f sub 3 is equal to 8. So it is now correct. And then we are going to find the specific term in this sequence. So we will try to find the 22nd term for this sequence. So we will use this formula. So we have fn equals 3n minus 1. So we have f sub 22 is equal to 3 times 22 minus 1. So 3 times 22 is equal to 66 minus 1. So our 22nd term is equal to 65. Now let us have our fourth example. We have 2, 3, 4, and 5. This sequence is composed of consecutive numbers starting from 2. And we obtained the value of the next term by adding 1 to the preceding term. So we have 2 plus 1 equals 3. 3 plus 1 becomes 4. 4 plus 1 becomes 5, and so on. However, we need to formulate formula or rule for this sequence in order for us to find the specific term easily. Since our pattern is increasing by 1 or positive 1, we can use 1n or n. Now, let us try to check if this rule will work in this sequence. So we have f sub n equals n. So this is the formula because our rule is n. Now, let us try to check the first term. So we have f sub 1 equals 1. So our value for the first term is 1. And then the value for the first term of our sequence here is 2. So we need to increase n by 1. And now let us try to check if we can get the value of 2 for the first term. So our formula will be changed into Fn equals n plus 1. Now let us check it again. So we have f sub 1 equals 1 plus 1 for the first term. So the value for our first term is equal to 2. So it is now correct. Now we will try the fourth term. So we have f sub 4 equals 4 plus 1. So our fourth term is equal to 5. So this is correct. Now, this time, we are going to look for the specific term using the formula that we have made. So we are going to find the 25th term in this sequence. So we have f sub 25 equals 25 plus 1. So our 25th term is equal to 25 plus 1 is equal to 26. So this is our 25th term using this rule or formula. So our formula is Fn equals n plus 1. So the rule for this sequence is n plus 1. So this rule will be used for consecutive numbers. Now this time, we will try to use fractions. For example, we have 1/2, 1/3, and 1/4. As you can see, we obtained the value of the next term by adding 1 to the denominator of the preceding term. So we have 1 over 2 plus 1 becomes 1 over 3. 1 over 3 plus 1 becomes 4. Since we have learned to our previous example about the rule for consecutive numbers or sequence, so we can just simply use 1 over n plus 1. Now let us try to check using this rule. So we have Fn equals 1 over n plus 1. Now let us check for the first term. We have f sub 1 is equal to 1 over 1 plus 1. So our f sub 1 is equal to 1 over 2. So it is correct. So our rule or formula for this sequence is 1 over n plus 1. Now let us have another set of fractions. We have 2/3, 3/4, and 4/5. As you can see in this sequence, the numerators and the denominators are increasing by 1. So 2 plus 1 becomes 3. 3 plus 1 becomes 4. And for the denominators, we have 3 plus 1 becomes 4. And 4 plus 1 becomes 5. Since our denominators are consecutive numbers starting from 2, so we can just use the last rule, which is n plus 1 for the numerator. But for our denominator, we still have to check if this rule will work for them. So let us try this rule to our denominator. So we have f1, or we are going to check for the first term if we can get the value of 3. So we have f1 is equal to 1 plus 1. So we are going to substitute 1 for n. So we have 1 plus 1. So our first term for the denominator is 2. So it is wrong. So now, what should we do? So we have to increase the value here. So we will add 1, or it becomes 2. So we have n plus 2, because we are going to add 1 for the denominator so that we can get the value of 3. Now, we are going to check if this rule or this rule of the denominator will work. So we have f sub 1 is equal to 1 plus 2. So we have 1 plus 2. So our first term for the denominator is equal to 3. So it is now correct. Now, let us try using the whole formula for the numerator and the denominator. And let us try to find out if this formula will fit for the denominator and the numerator. So we have n plus 1 over n plus 2. So we will try to check the third term. So we have f sub 3 is equal to 3 plus 1 over 3 plus 2. So our third term is equal to 4 over 5. So it is correct. Now we are going to find the specific term for this sequence. So we are going to use this formula. So for example, we are going to find the 10th term of the sequence. So we will just substitute 10 for n. So we have f10 is equal to 10 plus 1 over 10 plus 2. So our 10th term for this sequence is 11 over 12. Now let us practice this time. I want you to formulate rule or formula for this sequence and find the 12th term. I will give you 10 seconds to do that. Now, let us try to check your work. As you can see, the pattern in this sequence is increasing by 5. So we have 10 plus 5 equals 15. 15 plus 5 equals 20. 20 plus 5 equals 25. Since our pattern here is increasing by 5, we can use 5n as their temporary formula or rule. So we have fn equals 5n. Now, let us try to check if this rule will work. So we are going to check for the value of the first term. So we have f sub 1 equals 5 times 1. So the value for our f sub 1 using 5n is equal to 5. So we need to increase 5n to 5 so that we can get the value of 10. Now, let us try to check if this formula will work now. So we have f sub 1 is equal to 5 times 1 plus 5. So we have f sub 1 equals 5 times 1 equals 5 plus 5. So our first term is equal to 10. So it is now correct. Now let us try to check the fourth term using this formula. So we have f sub 4 equals 5 times 4 plus 5. So we have f sub 4 equals 5 times 4 equals 20 plus 5. So our fourth term is equal to 25. So it is correct. Now this time, we have to find the 12th term as required. So we have f sub 12 is equal to 5 times 12 plus 5. So f sub 12 is equal to 5 times 12 is equal to 60 plus 5. So our f sub 12 or our 12th term is equal to 65. Now let's proceed to our next lesson. So we are going to differentiate mathematical expression and mathematical equation in a brief way. So when we say mathematical expression, it consists of variables, numerals, and operation symbols, but it doesn't have equal sign. So it means it has no ending. So when we say mathematical equation, it contains equal sign and it shows answer or representing the value of the variable. For example, we have 2x plus y. So this is just a mathematical expression because it doesn't have equal sign and it doesn't have an answer. Next we have c plus 10 and we have 9 plus 21. So this is just an expression because it doesn't have equal sign and it doesn't show answer. While mathematical equation contains equal sign, it shows up answer or ends up representing the value of the variable. For example, we have 8 plus 7 equals 15. We have 29 minus 12 equals 17. And we have c minus 15 equals 44. So we can easily figure out the difference between mathematical equation and mathematical expression with the use of equal sign. So mathematical equation has equal sign while mathematical expression doesn't have equal sign. Now let us practice this time. I want you to write EX if it is an expression and EQ if it is an equation. So I will give you 10 seconds to answer this one. So time's up. Let us try to check your answer. So for number 1, it is EX. For number 2, it is EQ or equation. For number 3, it is an equation. For number 4, it is EX. And for number 5, it is EX. Alright, so that's all for today, and I hope you have learned a lot in our lesson for today, and see you on my next tutorial. If you feel satisfied on my videos, please like, share, subscribe, and click the notification bell so that you will be updated on our next lesson tutorials.